My name is Ravi Babu, Assistant Professor in Triple Department, IARE. We are going to seeing the stability analysis, where in last classes we see the stability concepts and some of the tests, that is jury stability and RH criteria stability. Now again I am going to analyzing on stability concept. That is, stability is nothing but it is the most important used in the control system design. Before discussing the stability test, we first introduce the following notations of the stability for linear time invariant systems. That is, Bibo stability or zero state stability. Otherwise, the second one is internal stability or zero input stability. Zero input stability. Initially, we say that generally in linear time invariant systems is said to be Bibo stable for a bounded input and the bounded output also will be bounded. However, similar to continuous time systems, the stability of the control system is defined for the transfer function. So first of all, the transfer function is nothing but the forward path to the function to the feedback path. So I am taking the forward path as g of s and taking the feedback path as a with negative feedback, that is negative feedback closed loop control system, that is 1 plus g into h of j. Now we can for finding the stability of the system, we now identify the poles and zeros location in a system. That is nothing but the denominator of the characteristic equation is called as a poles and denominator of the poles is called as a numerator of the poles is called as zeros and denominator is called as the poles. Okay, so for this one we have to analyzing the characteristic equation. Characteristic equation is nothing but the denominator part are equal to 0. The numerator part are equal to 0. That is nothing but the characteristic equation. So to determine the location of the closed loop poles in jet plane, we have to take in the characteristic equation. So from the system is stable when the closed loop poles on the right roots of the characteristic equation must be lying in the unit circle only in jet plane. Otherwise, it is not. It is contained of the unstable condition. That is, if you take any unit circle in case of the digital control system, unit circle, in that one, if the poles are inside, that is nothing but inside the unit circle, that is stable condition. Okay, outside the unit circle, that is unstable condition. So that is the first point is explain that one. And coming for the second one, when a simple pole lies on the z axis, that is z plus 1, that is magnitude of z equal to 1, in that one it is called as a marginally stable. Otherwise, one more thing is there, that is the multiple poles are the same location of the unit circle. That is the multiple poles here. The multiple poles on unit circle is repeated, then it is called as a unstable condition. Unstable condition. So this is the concept of the stability in discrete time analysis in jet plane. Now I am going to take into one more the problem. For example, that one. Why? Because already we studied the jury stability system in previous sections. So I am taking the one of the problem for this stable conditions or jury stability condition. So determine the closed loop stability of the system. Also is in figure 1 when k equal to 1. That is, they taking the amplified gain factor is forward path gain factor is one of the gain factor is 1. They are taking. Okay, so here R of S is the input signal and C of S is the output signal and E of S is the error signal and E star of S is the pulse transfer function of that one signal. That is with a time period of 1 second. So they given as the function is, that is one of the function is 1 minus e power of minus s by s. It is one of the function, forward path function. Another one of the forward path function is 1 by s into s plus 1. 1 by s into s plus 1. And they will be also given the g of s. G of s, one of the forward path is given again, that is g of s, and it is going to be added into the second function category. Second function category, that is here. After the second function, it is going to be adding in this function. So we have to find the stability of this system. Stability of the system. Okay. For that one, first of all, I am taking the Z transform of this total systems. Z transform of this total systems. So it is, first one is this one and second one is this one. So find the Z transform of these systems. That is nothing but here the 1 minus e power of minus s by s is nothing but e power of s is nothing but 1 minus z power of minus 1 into z power of 1 by s square plus s plus 1. So for solving this mathematical equation, we have to get as this one is the, so here they given as, since h of s is the 1, it is unity feedback. H of s is the 1, unity feedback, and whereas the g of z equal to g into g of z, and the transfer function is nothing but c of z by r of z equal to 1 by 1 plus g of z by 1 plus g of z. So for finding the stability condition, we are taking the characteristic equation equal to 0. That is, denominator part of this system is equal to 0. Denominator part of the system is equal to 0. That is nothing but we have to taking as, this is the system, z of z minus 1 into z by 1 by z of 1 by s square plus s1. So this is our system. So for that one, I am taking the characteristic equation of that one. Characteristic equation of that one, that is denominator part of that one. That is z minus 1 by z into z by z minus 1 whole square into 1 minus e power of minus z by z minus 1 into z power of e minus 1. Okay, e power of e minus 1. If you take this one, it is simplify this one mathematical equation, that is called as a, here z minus 1, z minus 0.366 and z minus 1, e power of minus 1 is nothing but 0.368 minus 0.368 into z plus 0.368. True. Okay. So taking the Z transform. Okay. So we have to calculation this one. We are getting as 0.368 plus 2.068 by z minus 1 by z minus 0.368. We are getting here. We are getting here. So for finding this one, we have got the one of the transfer function, that is 0.368 z by plus z 0.268 by z minus 1 into z minus 0.368. For taking the characteristic equation of this one, that is denominator part equal to 0. Denominator part equal to 0. Okay. So plus 1 plus g of z. G of z is nothing but this is the value, g of z value. So it is coming to 0. 1 plus g of z equal to 0. Okay. We got the g of z value here. Okay. So taking the equations, we got the z1, z2 values. That is nothing but mod z1 value is nothing but it is less than 1, and also similarly mod z2 value also will be less than 1. So we find the system stable condition. Here. System stable condition. So coming for the next one. This is a general method for finding the system stable conditions. Okay. However it may be, we have to find the system stable condition by not taking the catch equation. That is, we are going for the different type of tests. That is, Sapur-Kahn stability test and Jury stability test and House stability test. Other tests, stability tests like Lyapunov stability test is also will be available for the applications of state-based models, which we will discuss later. Okay. Computation required in Jury test is simpler than the Sapur-Kahn stability test, and the coefficient of the real with always true for physical systems. That is the main advantage of the Jury stability test. So we will see the already we see this one is in previous sections. What is my Jury stability test? Okay, so we are going to directly for the moving to problems. Coming for the one of the problem is Jury stability test problem. That is P of z equal to, take this one, that is P of z equal to z power of 4 minus 1.2 z cube plus 0.07 z square plus 0.3 z into 0.08 equal to 0. Here, what is the A naught? A naught is nothing but first term, highest power of constant term. Okay, that is A naught. Next one, A2 is nothing but 1.2, A3 0.07, A4 0.08. Sorry, A0, it is A0, A1, A2, A2, A3, A4. We got this one. Okay, so we can see what is the first conditions, necessary and sufficient conditions here. So first you have to take in the necessary conditions, that is the AN. What is the AN value? N value is here 4. N value is here 4. So N value is nothing but highest power of N. Highest power of N. So what is that one? N value is 4. So AN is nothing but what? N value is 4, no? That is A4. What is the A value? A4 value? 0.038. The magnitude of this one is, it is minus 0.038. The magnitude of this one is 0.08. And it is less than to A0, no? It is less than to A0. So it is the first condition we have to satisfy. We have to satisfy. Next, coming for the next one is substitute where the characteristic equation, polynomial equation here, this one with z equal to 1. Z equal to 1. Substituting the z equal to 1 here, 1 minus z equal to 1, no? That is 1.2 plus 0.07 plus 0.3 minus 0.08. The total value is coming to as 0.09. It is less than to 1. This is one of the second condition here, also will be satisfied. Satisfied. Next one is P of minus 1. P of minus 1. Substitute where P of minus 1 value here. That is minus 1 whole square plus 1.2. It is coming to 1.2 plus 0.7 and plus 0. P of minus 1. No? Z value is minus 1 here. So it is coming to as P of minus 1. Minus 3, 0. Minus 0.8. 0.8. Okay. So it is coming to as, what is the value? The value is minus 1 in substituting here. Okay. So it is value 1.89. That is greater than 0. That is P of 1 is greater than 0 and P of 2 is also will be greater than 0. That is nothing but it is also will be satisfied. After condition this satisfaction, we have to go for the jury table. We have to go for the jury table. Jury table. What is the jury table here? So how many jury tables will be coming here? That is nothing but for forming the jury table, that is we having there B3 value, that is AN minus A0. So AN minus A0 and A0 into AN. We have to find this value, that is coming to as minus 0.99636. Already explained in previous sections more problems. Once again I am repeating these problems like this. Okay. Okay. Next, coming for the B2. B2 nothing but what? AN, A1, AN, sorry, A0, AN, A1, A1, A0, A3, right? Okay. Okay. So this is your second value. So we got the value is 1.726. 1.726. So it is A1. Next, list of the people is, that is B1. B1 value is what? We got the 0.7536. So we got the B0, okay, and B C2, C1, C0. Okay, these are the values we have to find. So after finding these values, we have to see that one is B3. What is the B3 value? B3 value is 0.9936. Is greater than B0? Yes. Why? Because B0 value is 0.24, 0.204, 0.204. So it is greater than, satisfaction. And C2 value is 0.946. It is greater than the C0. That is 0.315. So it is also will be satisfaction. So the system is stable condition. System is stable condition. This is the way, simply way you have to identify. Otherwise, normal method is find the roots of this characteristic equation. Then from the roots, we have to analyze the magnitude of the Z value. Magnitude of the Z value. We can say that is stable or unstable condition. Okay. In this way, we have to solve the problems on jury stability system. It is very easy. Just a simplification of the small values. Only keep it 1, minus 1. After that, form the jury table. That is only. Okay. So, next, we will see the one more problem here. See, P of Z equal to Z cube minus 1.3 Z square minus 0.08 Z plus 0.34. In this one, what is the N equal to 3? N equal to 3. So, first term magnitude is A0. A0 equal to 1. A1 equal to minus 1.3. A2 equal to 0.08. A3 equal to 0.04. Where A3 equal to 0.24. It is less than 1. Sorry, greater than 1. Yes, it is greater than 1. So it is satisfied. It is satisfied. Next, step to the next one, P of 1. So when you have submit the P of 1 z equal to 1, at that case, that is coming to as 1, 1, 1.3 and z equal to 1 now 0.08 plus 0.24. That value is minus 0.04. That is your second condition. So it is not greater than 0. It is less than 0. So it is not satisfied. So what I am saying is, if it is not satisfied, then the criteria is going to be involved in is having a no value. We have to may stop the test here for concluding the system is unstable. System is unstable. Okay, that is P of 1 equal to 0 or P of minus 1 equal to 0 indicates the presence of the roots on the unit circle, and that case the system can be make it as a most become marginally stable or the rest of the conditions are satisfied. Satisfied. That's why we have to stop here for this one. So the stability range of the parameter can also be found from the juris table, which we will see in the next example. Okay. So see this one. This is the example. You have to find the k value for system where is the conditions are not satisfied. That is j of z equal to k into 0.368 z plus 0.264 by z minus 1 z minus 0.368. Okay. Now I am going to for simplification process. That is I am going to for the closure transfer function k into this value by denominator part I am going to multiply z square plus 0.368 k minus 0.368 z plus 0.368 into plus 0.068 264 k. That is one transfer function. Okay, what is this one? 1 plus g of s by 1 plus g of s into h of s. Okay, g of z by 1 plus g of z into h of this value is this one. This value is this one. Okay, take the Cauchy equation. So what is the Cauchy equation? Z square plus 0.368 k minus 0.368 z plus 0.368 plus 0.264 equal to 0. Okay, say okay. So what I am saying, it is a second order system. Okay, and only 3 stability conditions are there for this one. Okay, 3 stability conditions are there. That's why I am going to checking every condition. Coming for here, take the first equation. The Cauchy equation is z square plus 0.368 k minus 1.368 z plus 0.368 plus 0.264 k. Okay, so what is the A naught value here? A naught value is 1. What is the z equal to? So A naught, A1, A2, z equal to 2. So that is 0.268. So it is what is the A naught value? It is less than 1. It is less than 1. What is the P1 of 0? So P1 of 0 is coming to as greater than 0. And P2 of 0 is minus 1 equal. Since n equal to, even it is implies. It is not possible for there. That's why we are going to make it as so. See, for this one, A2 is 0.368 plus 2A2 less than A0 is 1. A0 is 1. Okay, so from this one, we find the k ranges between these two, 2.369 and between 5.168. Now, substitute the P of 1 value. When you substituting the P of 1 value, we got the value as 0.632 k. 0.632 k. From that one, k greater than 0. K greater than 0. Next, coming for this one is p equal to minus 1. Substitute the p equal to minus 1. When we have to substitute the p equal to minus 1, this is coming to as okay 1 minus 0.368 k plus minus 1.368 into p of minus 1. No, that is coming to as okay. So it is coming to as minus. So we got this values. That is, if the range is nothing but we are getting here. That is, the k value is between below this value. Below this value. From where? From k equal to 0 to. That is nothing but the k range will be between 0 and 26.38. 26.38. So, k value is between these values. Okay. So, finally, what I am saying is k will be found between 0 less than 2.39. If k equal to 2.39 becomes a critically stable condition. So, what happens that one? That is, it is coming to as characteristic equation as x square plus 4.0.48 plus 1. Okay. So, it is called as a with transfer function equation. From that one, we got the z value. From that one, we got the z value. So, with the ample period they given in a problem. 1 second. So, I am taking the here 1 second value, t equal to 1 second. So, what happened? The WD value. WD value is the formula is we know already in previous sections I told WS by 2 pi into mod z. So, WS value is 2 pi. WS value is 2 pi. And tan inverse of what the B by A value that is here, that is 0.937 by 0.228. Okay. Now, we can say that this is the frequency for sustained oscillations. Sustained oscillations. That is this value. 1.324. 1.324. Next one is, I am taking the another topic is singular cases. Singular cases. That is nothing but whenever the situation when sum of all the elements on the row in a dual table or 0 indicates the presence of the roots can be unit circle. Remember this one. That is nothing but whenever all the elements of the rows in a dual table are zeros. Okay. If any row it is coming to as 0, then all going to be taking a singular case first. Okay. It can be avoided by experienced persons only. Experience. Okay. Nothing but we have to conclude that one is extending the quadrating the circle of the uniformly by means of the which is equivalent to the Bernoulli system with zeta value. That is zeta. So what happens? Z value is 1 plus 0.1 into z into zeta is coming. Where is the zeta is nothing but it is a small number. When it is a positive, unit circle is going to be expanded. When it is a negative, unit circle is going to be contracted. Remember this one, very important. Why? Because the difference between the number of zeros found inside the unit circle, outside the unit circle, when the pole will be nothing but unit circle is explained or coordinated by the number of zeros and units. Okay. So what happened? It is coming to us within the unit circle. So what happened this one? Finally, we are saying that is the total singular cases is going to positive and negative, and the transformation equations have to be that is z power of top terms into going to be multiplied with 1 plus n zeta. 1 plus n zeta. So we will see this one for with applicable of one example. Applicable of one example. So taking as a transfer function of the binomial equation, that is z cube plus 0.25 z square plus z into 0.25. Okay. What is the A0 value here? Already most problems I have to consider here. A0 value is 1, A1 is 0.25, A2 is 0.25. Okay, A2 is 0.25. Sorry. Third, no. A0 equal to 1, A1 equal to 0.25, A2 equal to 1, A3 equal to 0.25. 0.25. What the AN value is? Here AN value is A3 value, that is 0.25. Okay. What the A3 value is here? That is 0.35. A3 also will be coming as 0.35. So finally, what is this one? It is value is 0.25. So what happened this one? This is less than the A0. What is the A0 value? That is 1. So what I am saying is the first condition is going to be satisfied. First condition is going to be satisfied. Now I am going to moving the one of the content as that is P of 1. Okay, if you submit the P of 1 value, we got the P of 1 value is 2.5. 2.5. It is also greater than 0 now. It is also greater than 0. So what happened? This is the second condition is going to be satisfied. Next one is I am going to P of minus 1. P of minus 1. Substituting the P of minus 1 in a polynomial equation, we got the 1.35. 1.35. It is less than 0. It is less than 0. Minus 1.35. Minus 1.35 we got. Negative value. That's why it is also will be less than 0. Third conditions are not satisfied. Now, I am going to with the jury table. I am going to with the jury table. So what happened in this jury table? That is, how many rows is coming? 3 rows. Okay, 3 rows. So what happened? 0.25. This one in this direction. How many are there? 3 rows. It is depending upon the power of the this one. Power of the this one. So what is the value? That is, what is the values here? Okay, so it is 0. In this way, you have to write down first of all. So 0.25, 1 plus zeta, 0.25 into 1 plus zeta plus last one is 1 plus 3 power 3. 1 plus 3. Okay, 1 plus 3. Next one is go to in this way, second row. In this direction. That is 1 plus 3, 0.25 into 1 plus 3, 1 plus 3 plus 0.5. 0.5. 0.5. Okay. Now, coming to 5 here, how can you get this one value? Apply the matrix formation. Apply the matrix formation. What is that one? That is 0.25. Okay. Into. So, 1.3. 0.25 into 1.23 by, okay, by, that is, sorry, not by, second first equation. Next one is minus, AD minus BC. 1 plus 3 epsilon E square plus 3 epsilon E square. So we got the value. That is B2 value. 9. Okay, we got the B2 value. Similarly for B0. This is the value. Finally, what I am saying is, whenever zeta value is greater than plus 1, that is, it is lying between these two values. It is lying between these two values. That is the answer. Okay, that is, which implies that the roots are not on the unit circle. Actually, inside the system, marginally stable. But the roots of the classification are found that as plus or minus j 0.25, which is into that is a conclusion for this one. Okay, next. Okay, thanking you. We'll see the next class. One more problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.